Well, so hi everybody. So we're going to talk about the part 2 of chapter 3, which is the measures of spread. And last time we talked about measures of center by using mean, median, and a mode. And for different cases, you may choose different measures. This time, we'd like to look at measures of spread of a data set. For this topic, we'll be talking about concerning both sample and a population. Okay. And basically, the spread is talking about the variability of the data, which means how much the data is going to vary. Okay. So both for sample and a population. So sample or population. We would like to focus on two kinds of measure of spread. One is called the range, which is very straightforward. And the other one you probably have heard a lot in different reports called standard deviation. We will also look at some of the special ones, which is the extremely big number or extremely small number. Those are called outliers that we have seen before. Okay, so let's begin with range. Range is relatively easy to calculate. Okay, it's computed by using the difference of two numbers. So basically, range is just the maximum number of the data set subtract the minimal value of the data set. You find the highest number and then you subtract the lowest number. That's the range. Tells you how far the lowest is away from the from the highest. So let's suppose we have example 1 here. We're given with these 5 numbers, 25 through 100. And this is not sorted as of now, right? So not sorted. Even though it's not sorted, you can see the mean value, the minimum value is 20, the smallest, and the highest value is 100. So the range will just be the difference of those two, which will just be 80. Second example, we have smallest number is 67, and highest number is going to be 73, very easy to identify. So let's subtract those two numbers, and it turns out to be the range will just be 6. So range is easy to compute. Now, if we just compare these two sets, we see the first range is 80 and the second range is 6. If you use a number line, right, we can put the number lines here. Let me get my pens activated. So the first one has like 80 as the range, it's that big, and the second one has only 6 as the range. So it's easy to see the set 1, the first set, with the range of 80 is more spread out than the set 2, which is has only a range of 6, which is quite obvious here. Some important property of range that we need to emphasize. First of all, the range only uses two numbers, the highest and the lowest. It doesn't consider any of the rest of the data values in the set. If these two numbers are affected by the outlier, then the range will be affected by outlier. So the range is not resistant to outliers. Okay. We've talked about in central tendency, like the mean is not resistant to outliers, which is sometimes we can't use the mean for measurement of center. So same thing here, range is not very ideal sometimes. The other thing we just mentioned, range only uses the maximum and the minimum. It doesn't take every value. Okay, so it has its shortcoming. So instead of using range for a quick computations, a lot of times we do standard deviation for the variations. So standard deviation is the standard way for us to measure how widely spread out the data are. Okay. The standard deviation is a measure of the distance that a typical observation would be away from the mean. Okay. So it's kind of like talking about the average distance of each observation from the mean. Some property of standard deviation that's important is we're comparing, okay, each data value and how much they would go away from the mean. Okay, what's the distance between data value and the mean? And the value of the standard deviation here is never negative. Okay, it's always positive. and sometimes it's 0 only when all the values are exactly the same. When they're all the mean, then the standard deviation will be 0. It's kind of rare. If you have a larger value of standard deviation, then it indicates larger variation of the data set. Also, for standard deviations, it can increase dramatically with one or more outliers, so it's also not resistant to outliers. Okay. The units of standard deviation are the same as the units of the original data values, so they would carry the same units if you are considering some application questions. Okay. The units of standard deviation are the same as units of the original data values. Okay, as we just mentioned, standard deviation is important in the sense it tells you how far each data value is away from the mean. So I want to emphasize one more time, a smaller standard deviation means most of data, they are very close about the center, okay, to the center. A larger standard deviation means the data are actually more spread out, okay. All right, now let's see how do we compute the standard deviation, okay. And before we compute the standard deviation, we need to understand the symbol for standard deviation. So the symbols are important, like the mean that we have seen. Sample mean is X bar, population mean is mu, okay. So previously we have X bar versus mu, right? X bar versus mu for means. Now, this time when we're looking at a standard deviation, you should also consider for sample and for population standard deviation. For sample standard deviation, we use lowercase s. For population standard deviation, we use sigma. Okay. There is another name for the standard deviation which is important. For population standard deviation, it's also called unadjusted standard deviation. For sample standard deviation, it's called adjusted standard deviation. Okay. Because they are different in terms of computation, we have to adjust the denominator later on. That's why for sample standard deviation, you have this keyword adjusted. Okay. And a lot of times we use sample standard deviations to estimate a population standard deviation when a population standard deviation is not given. Your textbook use SD for standard deviation, okay, usually is for population standard deviation, okay, in your textbook. So next, let's get down to the business of seeing how we compute standard deviation. Okay. Let's first look at the formula for computing unadjusted standard deviation, which is the population standard deviation. So use the symbol sigma. And the formula is like this. First of all, you have a big square root, and inside the square root, you have a fraction. To the denominator is n, and recall what this n represents. That means the size, right? Size of the population. And on the top, you have this x, which is each data value. And this n for your textbook, m is for population mean. So basically we do square root of the sum, okay, for sigma sign, of each data value, subtract mean and the square, and then you divide by the size of the population. Once you get that, you take square root. That's going to be the population standard deviation, or sigma. Looks complicated, but it's not that hard as appears. So let's look at the following example. So suppose we have 67, 68, 70, 72, and 73, these 5 individual data value. Okay. So first of all, we can compute the mean, which is 70. Okay, I'm going to use the notation here. 70 is going to be the mean. So in your textbook, they use m. We can also use mu for population standard deviation. So in order for us to do this formula, we'll first of all find sum of x minus m squared. Okay, so let's first focus on x minus m squared. The x minus m basically is x minus m is just talking about take each observation and subtract mean and then square the result. Okay, and then we consider the sigma, which is take the sum. So let's do x minus m squared first, which means we have mean is 70, so we do 67, subtract 70, and then square that. Okay, so 67, subtract 70, square, you get 9. Next observation, we have 68, so we subtract 70, and then square that, you have positive 4. Okay, 70 subtract 70 square equals to 0. 72, the same thing, you get 4, and 73 is 9. This column we have here, this column is x minus m squared. And notice that all of these numbers you have, they are positive, right? They're positive. So they're positive, greater than 0, positive, and positive. You don't have negative numbers. So we've found this x minus m squared for each individual observation. Next, we'll just be finding the sigma. Okay. So we just need to add these things up. Okay. So we found the sum them up, and this will give you 26 for the sigma. So then we'll just need to apply that formula. Sigma equals the square root of sum of x minus m squared divided by n. Over here, the n talks about the number of items in the data set. We have 5. Okay. So here you have 67 to 73. There are 5. So n equals 5. Let's see. That's right here. So n equals 5. Okay. So we're just going to plug this in. You get a square root of 5.2, which is 2.2804. Okay. All right. Over here, we have seen that's an important part of computation. We do sum of x minus squared. That quantity, that amount, okay, is called sum of the squared deviation. It's called SS, sum of squared deviation. So the variance is just mean of the squared deviations. The standard deviation is the square root of the mean square deviation. Okay, so I'm going to explain this over here. So basically we have this part over here, this item, which is the mean of summed square root of deviation. That's called variance. So that's square root of the variance. So this part is variance. And this top, this little thing on the top, the sum of x minus square, that's called a sum of the square deviation. So as you have seen, standard deviation is square root of variance. So when we look at variance, okay, variance will just be the square of the standard deviation. Okay. They have the relationship between each other. Okay, so variance is square of the standard deviation. The symbols are then we have for sample variance, we have x squared. For population variance, we have sigma squared. Okay. It's not very useful our purpose. Okay, we use that a lot for normal distributions. Let's see in our case, what's the sigma square. So basically the sigma square is the item that you have seen underneath the square root. Okay, so that is our sigma square. Okay, sigma square equals to 5.2 in this case. All right, so that finishes the variance. For the next video, we're going to talk about sample standard deviation, which is the adjusted standard deviation.